Hello guys, in today's video we are going to discuss the solution of the problem Rohan's love for matrix. So let us look at the problem statement. The problem statement says that Rohan has a special love for the matrices, especially for the first element of the matrix. Being good at maths, he also loves to solve the different problems on the matrices. So one day he started to multiply the matrix with the original matrix. The elements of the original matrix are given by 1, 1, 1 and 0. Given the power of the matrix n, calculate a to the power n. So let us try to understand the problem statement with the help of an example. So the original matrix which is given to us is this. So this is the original matrix which is given to us, and let us call this matrix as A. And a power is given to us. So let us say in our example n is equals to 2. So that simply means we want to compute a to the power 2, which is a square. So let us compute a square. A square equals to a into a, and if we compute a square, the output we will obtain is something like this. So what the problem says is our original matrix is given to us, which is A, then n equals to 2, or a value of n is given to us. So we need to compute a to the power n. Over here n equals to 2, so we need to compute a square. And once we have computed a square, we need to return this element, which is a, 1 and 0. So that's about the problem statement, folks. Now let us discuss the solution for this problem. So let us first discuss the brute force solution of this problem. So in the brute force solution, what we are going to do is we are going to compute a to the power n. And once we have computed a to the power n, we are going to return the 0th element of the first row. So that's the brute force solution, folks. Now let us discuss the optimal solution for this problem. Well, the optimal solution relies on the fact of finding pattern for a 1 comma 0, which is 0th element of first row of the matrix. So what do I mean by this is, so let us take our original matrix. So our original matrix is A, and over here the matrix which is given to us is 1, 1, 1 and 0. The 1 comma 0th element is this. Now let us go ahead and compute a square. So as we know, a square is essentially a times a, which is equals to 1, 1, 1, 0, and let us multiply it with 1, 1, 1 and 0. So if you multiply this, the resultant matrix will look something like this. And over here in a square, the 1 comma 0th element is this element. Now let's move forward and compute a cube. So a cube is essentially a into a square. So let us do that. And if we multiply these two matrices, the resultant matrix will look something like this. And over here, the 1 comma 0th element is this. Now let us go ahead and compute a to the power 4. Following the same logic, a to the power 4 is a times a cube. So this will be equals to, and if we multiply these two matrices, the resultant matrix will be, and over here, the 1 comma 0th element is this. Now let us compute a to the power 5 also, and a to the power 5 is equals to a into a to the power 4. Now let's perform the multiplication, and if we multiply these two matrices, the resultant matrix will look something like this. And in this, the 1 comma 0th element is this element. So far we have computed a square, a cube, a to the power 4 and a to the power 5. Now using the 1 comma 0th element, let us try to find out if there exists a pattern between these elements or not. So the first element was 1, and in a square the element which we are interested in is 1 again. In a cube the element which we are interested in is 2, and in a to the power 4 the element which we are interested in is 3. Similarly, in a to the power 5 the element which we are interested is in 5. So if we look at the elements carefully from here, then this element is the sum of the other two elements, right? 2 equals to 1 plus 1. Similarly, 3 is equals to 1 plus 2. So let me write it down. 2 equals to 1 plus 1. 3 is equals to 2 plus 1. Similarly, 5 is equals to 3 plus 2. And if this pattern holds, then the next element, as we can predict it, should be 8. So now let us try to actually go ahead and compute a to the power 6, and let us see what will be the value over there. So a to the power 6 is equals to a into a to the power 5, and this is equals to matrix 1 multiplied by matrix 2. And if we multiply these two matrices, the resultant matrix which we will find is 13, 8, 8 and 5. So the 1, 0th element is 8, as we have predicted over here, right? Just for the sake of completeness, so 8 we have obtained it how? 3 plus 5. So now if you see, the next element should be 8 plus 5, which is equals to 13. So 13 is equals to 8 plus 5. So let us go ahead and compute a to the power 7 also. So if you see, a to the power 7 is equals to a into a to the power 6. And if we multiply these two matrices, then the resultant matrix will look something like this. And over here, the 1, 0th element is 13, as we have predicted using this pattern. So let us discuss the pseudocode for this. So we want to compute the first element, and let me write the pattern also over here. So 1, 1, 2, then 3, 5, 8, 13 and so on. So this is the pattern. So what we are going to do is, we are going to say if n is equals to 1 or n is equals to 2. In each case, so I'm talking about n equals to 1 or n equals to 2. So in either of these cases, we just have to simply return 1. Otherwise, we will say our first value is 1 and our second value is also 1. And then we are going to set I equals to 3, and then we are going to iterate while I is less than or equals to n. And then simply what we need to do is, we need to find this third element, which is the sum of first and second element. And once we have found out this element, we need to update our first and second element. So let us update that. So our second element becomes our first element, and our third element becomes our second element. And let's not forget to increase our ith counter, and towards the end we are going to return third. So that's the discussion about the solution, folks. Now let us see how we have implemented this in Python. So the implementation in Python is same as what we have discussed in our pseudocode. Over here, if n equals to 1 or n equals to 2, we are returning 1. Otherwise, we have two variables, first and second, and the initial value is 1. As mentioned in the question, we have to perform mod operation also, since the sum of two numbers could be very large. So this is the mod which we need, and then I equals to 3 and initial value of third equals to 0. Then we are iterating while I is less than or equals to n, and we are computing the third, which is equals to first plus second mod, and then we are updating our first and second element, also our iterative counter, and towards the end we are returning third. So that's about the code, folks. Now let us go ahead and submit our solution. So our solution got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.